This is our grinding mechanism. It consists of a round file, a motor, and a 3D printed sleeve that features tapered threading throughout its inner diameter. Our cooling mechanism features a water jacket made of PVC pipe which houses our grinding sleeve. Here is a picture of our 3D print. These holes inside the inner wall of our grinding sleeve will allow for water flow to circulate the sleeve. Connected to our water jacket is the water pump that directs the flow of the water into the spiraled copper tube. A vinyl tube then connects the copper tube back to our water jacket, and that completes the water flow of our cooling mechanism. The biopellets enter through this cone where the grinding happens. The pulverized material is then collected using the force from a cyclone. And here's our device in operation. We first see the grinding mechanism in action, grinding our test material. We then see the water flow of our cooling mechanism. Next is the Arduino system that records our temperature data. And finally, we see our cyclone vacuum combination responsible for collecting our particles. The thermocouple is K-type and can measure temperatures ranging from 0 degrees Celsius to 300 degrees Celsius. Other components used in the system was the Arduino Uno, a breadboard, a thermocouple amplifier, and an LCD display. The sensor is located inside the water jacket to collect the temperature of water that is located inside of this structure. Because of the thermal properties of water, we can assume that the temperature of this water and that of the grinding mechanism are the same. To put the sensor here, a hole was drilled at the top of the water jacket and the sensor was slid through it. This hole was then sealed with a watertight marine adhesive. The temperature data was then collected and displayed on an LCD over a period of time. The vacuum is responsible for pulling air through the cyclone separator and the sleeve. This airflow moves our pulverized particles from the bottom of the grinding mechanism to our collecting tank, seen here to the right with the orange lid. It also acts as an additional cooling method. The water jacket is our main cooling mechanism. Inside of this cylinder, made of PVC pipe, is the 3D printed sleeve that was shown earlier. Water flows in through the vinyl tubing at the top of the cylinder, fills the space and holes within the sleeve, and then flows out through the vinyl tubing located at the bottom of the cylinder. This water pump is responsible for creating the movement of the water. It can move 1.6 gallons of water per minute and has a horsepower of 1/10 HP. Pictured here is the water bucket housing the water reservoir and the copper coil attached to our flowing water system. The flowing water system is a closed system, including the two clear vinyl tubings, the water pump, and the copper coil. The copper tubing is coiled to lengthen the amount of tubing that can fit into the bucket, which increases the surface area that is able to be cooled. This tubing exchanges heat with the cooler water of the reservoir located inside the bucket. The water inside of the water bucket is not a part of our water system. Its purpose is solely to cool the water flowing through the copper tubing. Our last featured part is the motor and file. The motor is a 12-volt DC motor. It is attached to a wood structure via a mounting bracket. A blue coupler then attaches the motor and the file. The file is a 10-inch round file and is responsible for grinding the material in cooperation with the sleeve. These two devices have congruent threading so that material is able to travel downward whilst being pulverized. Now that we have gone over all the mechanics of our device and highlighted all of the important features, let's watch the device in action one last time.